Here in the I button and description box below, you will get the complete playlist of multiple integrals. Welcome to video number 13, and in this particular video we are going to solve an important problem on the topic, that is change of order of integration. This question is also important. If you go to the playlist, you will find these four problems on the topic, that is change of order of integration, and all the questions are very important. In the next video, that is in video number 14, we are going to solve the most important problem of this topic, that is this problem. So don't skip this video. Okay, so let us start with this very important problem. That is, question says change the order of integration of I equals to double integral limit goes from 0 to infinity and x to infinity. The function given is e to the power minus y upon y. The order given is dx dy. First of all, we need to check whether this order of integration is correct as per the given set of limit or not. So here you can see in this the limit is from x to infinity. Since we have x here, so we can say this is the limit of y. Okay. Since here we have limit of y, so first we need to write dy. That means the order of integration given in the problem is wrong. So we need to correct this first. Okay. So if this is the limit of y, then this is the limit of x. So we can say given I equals to double integral 0 to infinity x to infinity e to the power minus y upon y. The order of integration should be dy dx. Why? Because this is the limit of y. So first we have to integrate this function with respect to y. So here in place of dx, it should be dy, then dx. Okay. Now moving ahead, here we can see that is old limit varies from y equals to x to infinity and x equal to 0 to infinity. So first we will write this part, that is limit of x, because limit of x is constant. X equals to 0 to x equals to infinity. Then followed by this, that is y equals to x to y equals to infinity. Fine. Now looking at this, that is y equals to x, we can say this is the equation of a line. No problem up to this, I believe. Now let us draw. Yes, this is y-axis and this is x-axis. This is y-axis. Fine. Now here x equal to 0 means this line. This line is x equal to 0. And x equals to infinity means this line. Suppose this line is a x equal to infinity. So then we have y equals to x. Suppose this line is y equals to x. Suppose this line is y equals to x, and here we have x equals to infinity. Suppose this line belongs to x equals to infinity. Okay, and we have y equals to infinity. Suppose this line is y equals to infinity. This is y equals to infinity. Fine. So all the points are covered here. No problem up to this. Now, what is important? That is, we must understand the strip is whether it is vertical or horizontal. Looking at this, that is, first we have first we have limits of y. Then we can say the strip is parallel to y-axis, or you can say the strip is vertical. Then we must understand where it should be, whether it is here or here. The vertical strip may be here or here. If we consider the vertical strip as here, so the lower limit of y-axis should be 0 and upper limit of y-axis should be upper limit of y should be y equals to x. I am repeating this once again. If I draw a strip here, then the lower limit is at y equal to 0 and upper limit is at y equals to x. But if I draw a vertical strip here, you can say the lower limit of y is at y equals to x and upper limit of y is at y equals to infinity. So this strip is okay. Now naming P and Q. First we have to name the lower part of the strip, then upper part of the strip. Okay, this is how we name the strip. Now here again you can see it will move from x equal to 0 to x equals to infinity. X equal to 0 to x equals to infinity. Fine, this is okay. Now we need to change the strip. We have to change the strip. You can, if you wish to draw another strip horizontal, you can draw here, but I am drawing this is x-axis, this is y-axis. Now this is y equals to x line. This line is y equals to infinity, and this line is x equals to infinity. This line is x equals to 0. Okay. Now, since the old strip is parallel to y-axis, then here it should be parallel to x-axis. If it is vertical, this has to be horizontal. Naming should be like R, S. That is, first we will name the left part of this horizontal strip, then we will name the rightward part of this horizontal strip. Now, from here we can say that is let RS be the new strip, and limit varies from here. In the old limit, first we wrote about x limit, then y limit. So here we need to write first y limit and then x limit. So here you can see RS, as per the y, it goes from y equal to 0 to y equals to infinity. So y limit goes from y equals to 0 to y equals to infinity. Once again, let us check. RS moves from y equal to 0 to y equals to infinity. Okay, from here to here. Y equal to 0 to y equals to infinity, and x equals to, if you take the leftward part, that is R, it is on x equal to 0. That is x equal to 0 to, if you see the rightward part, that is S, it is on the line which is y equals to x. So we can say x equals to y. So we can say the limit of y goes from 0 to infinity, and the limit of x goes from 0 to y. So after this, we will change the order of integration. So on changing the order of integration, we will write I. Which I? This I or this I? We will write first this I, because in this the order of integration is right, this is wrong. So we will write first this I. That is, as per the old strip, I equals to double integral 0 to infinity x to infinity. The function is e to power minus y upon y. The order of integration is dy dx, because this is the limit of y. So first we are writing dy, then followed by dx. So we can change this. The limit should go from 0 to infinity, then 0 to y, 0 to y. The function is as it is, that is e to power minus y upon y. Order should be changed, dx dy. This is the limit of y, sorry, this is the limit of x. So we are writing first dx. Since here we have y, so we can say this is the limit of x. So this order of integration is correct. So we have already changed the order of integration. Now we will solve this. For this, we will solve this part first. That is, we are solving this function with respect to x, and then the limit will be from 0 to y. Again, here you can see, that is, here we have function of y, but we are integrating with respect to x. So we will consider function as 1. So we will consider this as constant. So integration 0 to infinity e to power minus y upon y. Integration of 1 with respect to x will become x. Limit goes from 0 to y. Don't forget to write this dy. Now again, 0 to infinity e to power minus y upon y. On putting the limits, that is upper limit minus lower limit, this will become y minus 0, that is y. Now dy. Again, y gets cancelled. Solving this, that is integration 0 to infinity e to power minus y dy. Now integrating this, you will get e to the power minus y upon minus 1 because the coefficient of y is minus 1. So in the denominator part we have minus 1, limit goes from 0 to infinity. Now how to solve this? We will take this negative part, okay, and we will write this as 1 upon e to the power y. Limit goes from 0 to infinity. Now putting the limits, that is minus of 1 upon e to the power infinity minus 1 upon e to the power lower limit, that is 0. Now here we have 1 upon e to the power infinity. What is e to the power infinity? That is infinity. And 1 upon infinity is 0. I am repeating this once again. E to the power infinity is infinity. 1 upon infinity is 0. So we can write minus of 0 minus, here we have e to the power 0, that is 1. 1 upon 1, that is 1. So closing this bracket, here we have minus of minus 1, that is 1. And this is my final answer. Okay. Thank you. Thank you so much.